Hi everyone, welcome back to my YouTube channel. So this video is on the rabbit problem. First of all, I will give you guys a quick intro to this rabbit problem. This rabbit problem is one of the example problems which uses the recursive functions. Also, it's one of the simplest and story-like way of seeing or understanding what a recursive function actually does. So now I will tell you guys a story about this pair of rabbits. So assume we have a pair of rabbits, newborn rabbits, and also we are assuming that these rabbits never die. So as I said earlier, we are starting exactly with one pair of newborn rabbits. And these rabbits take 1 month to grow into breeders. That means grow into adults. Also, every month each of these adult pairs produces another newborn pair of rabbits. This is the story of this rabbit problem. So this may sound simple to you, but this leads to one of the famous patterns of maths, which is the Fibonacci sequence. Now let me explain this further with a little drawing. So as you can see, in the month 0, as I mentioned earlier, we have a pair of baby rabbits. Now our total pair of rabbits is 1. Now when it comes to month 1, they take 1 month to grow into adults, and now this baby pair has grown into adults. No newborn pairs right now. At month 2, this adult pair remains the same, and now they have produced another pair of newborn rabbits. So now at month 2 we have two total pair of rabbits. Now at month 3 we have 3 pairs of rabbits. The adult pair of rabbits in the previous month remains the same, and now they have produced another pair of baby rabbits, and the baby rabbit pair at the previous month has now grown into adults. Therefore, total number of pairs is 3. When it comes to month 4, the adult pairs in the previous month remains the same, and each adult pair of the previous month has produced another pair of newborn rabbits. So this adult pair has produced 1 newborn pair of rabbits, and this pair of adult rabbits also has produced a newborn pair of rabbits, and the baby rabbit pair in the previous month has now grown into adults. And in month 5, the adult pairs in the previous month remains the same, and each adult pair in the previous month has produced 1 pair of each one of them have produced another pair of newborn baby rabbits, and the baby rabbit pairs in the previous month has now grown into adults. So therefore in month 5, when it comes to month 5, total pair of rabbits is 8. So as you can see, we can continue this for on and on and on, and let us discuss the problem statement of this rabbit problem next. Now let's look at our problem statement like this. In month 0, we have 1 pair of rabbits. They are baby rabbits. In month 1, the baby rabbit pair has now grown into adults, but still the total number of pairs is 1. So now from month 2 onwards, we need to have a way to predict the total pair of rabbits at any month, at any given month n. So that is basically our problem statement. Simply, when we are given a month, we must have a method to say the total pair of rabbits at that given month. I think you guys can remember that I have mentioned earlier in this video that this rabbit problem leads to one of the famous mathematical patterns, which is called as the Fibonacci sequence. Basically, this rabbit problem is all about this Fibonacci sequence. So now let's implement this Fibonacci sequence in Java. Now let's go through this code line by line. Before, let me quickly tell you about what recursion is. Recursion means that a function calling itself directly or indirectly, and this corresponding function is called a recursive function. As you already know, a recursive function has two parts: base case, which is the stopping condition, and the recursive case, which is the function calling itself. So when it comes to this method, this is also a recursive method, and this recursive method we use to compute the Fibonacci numbers. And in this recursive method, our base case is this. This is our base case, which is if n equals 0 or n equals 1, return n. This is our stopping condition, and this prevents infinite recursions. And our recursive case is here, n greater than or equals 2. This is our recursive case. So if n greater than or equals 2, it breaks down this problem into two smaller sub-problems, which is computing fib n-1, and the other sub-problem is computing fib n-2. So this is our base case and this is our recursive case. So why we call this recursive? We call this recursive because inside this else branch, we call this function twice on smaller arguments, and we do this again and again until our base cases hit. So that's why this becomes a recursive function, because this function is calling itself again and again on sub-problems. Now let's understand our recursive function using an example. So our function name was fib, and let's take 4. So this hits our recursive case, right? So our recursive case was n greater than or equals 2, return fib n-1 plus fib n-2. So since this hits our recursive case, we can break this down into two smaller sub-problems, fib 3, fib 2. Still these two hit our recursive case. So fib 2, fib 1. This one still hits our recursive case. So fib 1, fib 0. So this hits our base case and this is our stopping condition. So if fib 0, we have to return n, which is 0. If 1, we have to return n, which means 1. Here also it's returning 1. this side we can further break down into two smaller problems, fib 1, fib 0, and this returns 0 and this returns 1. So when we add our returning values, it is 3. So the result of this is 3. So this is how we can understand our recursive function using an example. Earlier we used the recursive approach to compute the Fibonacci numbers, where we had a function calling itself multiple times. But here in this iterative approach we use loops and we use variables which we update until a certain condition is met. So in this method where we calculate Fibonacci numbers, we have used a for loop, and also we have some stopping conditions as well, just like in the recursive approach. If n equals 0, return 0. If n equals 1, return 1. And these are our variables which we update until a certain condition is met. And as I mentioned earlier, we have used a for loop to compute the Fibonacci numbers in this iterative approach. However, what I want to mention is that even though both this recursive approach and the iterative approach gets us the same result, they can be quite different in certain ways. Like the recursive approach is however very slow and it repeats some calculations multiple times. Therefore, it cannot be used for larger values of n. However, it's very easy to understand the recursive approach. So, it's best to use the recursive approach when your goal is clarity, not performance. So, in the iterative approach, it's very fast, efficient and work best for larger values of n. However, it's more complex to understand. So, it's best to use the iterative approach when your goal is performance and efficiency. But note that the iterative approach doesn't look like the Fibonacci definition, but the recursive approach looks like the Fibonacci definition. Since we know about the rabbit problem and the Fibonacci sequence now, let's look at the uses of Fibonacci sequence. Firstly, we can say that the Fibonacci sequence can be used to understand the recursion, like how a function can call itself, and also this recursion is a very common concept used in tree traversals or factorials, etc. So we can use it to understand recursion. Also, we can see this Fibonacci pattern in nature as well. So, sunflower seed spiral. I guess you all have seen a sunflower seed spiral, and it is also in this Fibonacci pattern. Also, pine cones and pineapples follow this Fibonacci patterns as well. So we can say that even the nature is using Fibonacci to grow efficiently and manage the space more efficiently. Also, we can see these Fibonacci patterns in art and architecture as well. So we can use this Fibonacci pattern in the form of golden ratio when it comes to art and architecture as well. Further, we can use this Fibonacci pattern in dynamic programming as well. So these are the basic uses of Fibonacci sequence. Okay, now we have come to the end of our video. So let's quickly go through what we have discussed today. So first of all, we discussed about the rabbit problem, which is our main topic of this video. Then we talked about the Fibonacci sequence, how rabbit problem leads to the Fibonacci sequence. And then we discussed about how recursion can be used to define this rabbit problem. And then we implemented this Fibonacci sequence in Java code. And then we talked about the two approaches, which is the recursive approach and the iterative approach, and we discussed about the differences of them. And finally, we discussed about the uses of Fibonacci sequence in real life. So that's what we discussed today in this video. So in conclusion, we can see that Fibonacci sequence is not just a math matter, right? It's a beautiful concept which connects math, nature and computer science together. So next time you see a spiral in a flower or solve a coding problem, remember Fibonacci might be behind that. So I hope you guys have learned something about the Fibonacci sequence and the rabbit problem through this video. So thank you very much for watching this video and stay tuned for more videos.